Welcome class. Today I will be teaching you about light in our lives, focusing mainly on the electromagnetic spectrum. Now, can anyone tell me the waves that make up the electromagnetic spectrum?
The electromagnetic spectrum consists of radio, micro, infrared, visible light, ultraviolet, X-rays, and
gamma rays, being the most energetic type of wave in the electromagnetic spectrum, which also makes it the most dangerous wave. Now, can you tell me what the visible colors are?
Oh, that's easy. Red, orange, green, blue, indigo, and violet.
You forgot yellow, but good job. Wavelengths are what we use to measure waves, which is the distance from the peak of one wave to the peak on the next wave, looking something like this, where this would only be one wave. While frequency is how many waves there are per second, so there would be two.
Oh yeah, I remember learning about this. Wavelengths can be measured in centimeters, millimeters, meters, kilometers, and nanometers, right?
Yes, they are. Somebody did their homework.
But what is the frequency of the waves measured in, teacher?
They're measured in hertz, which is 1 wave per second, kilohertz, which are 1,000 waves per second, megahertz, which are 1 million waves per second, most commonly used on FM stations, and gigahertz, which are 1,000 million waves per second. Now, can anyone tell me what objects prevent light from shining through?
Oh, pigment.
Matt?
Opaque materials. They do not allow light to pass through. In opaque materials, any coordinated vibrations given by light to the atoms and molecules are turned into random kinetic energy, or in other words, internal energy.
Correct. An example of an opaque material is metal. In metals, the outer electrons of atoms are not bound to any particular atom. They are free to wander with very little resistance throughout the material.
Wow, I'm learning so much already.
This is the reason why metals conduct electricity and heat so well. And while electromagnetic waves may seem to be fun learning, they can be harmful to your health and cause cancer from too much exposure to certain waves.
Oh, I know which light causes cancer. It's the ultraviolet rays. The UV rays have a shorter wavelength than visible light, making them invisible to the human eye. Also, excessive exposure to these rays can cause cancer because it can cause damage to the genetic material in your skin cells. This is my second year taking this class, so I already know.
Just like how you have history of physics, so does electromagnetic waves. In the 1860s and 1870s, a Scottish scientist named James Clerk Maxwell developed a scientific theory to explain electromagnetic waves. He noticed that electrical fields and magnetic fields can couple together to form electromagnetic waves. He summarized this relationship between electricity and magnetism into what we now refer to as the Maxwell's equations. Now, who can tell me who applied Maxwell's theories?
Oh, that's Hertz. He was a German physicist who applied Maxwell's theories to the production and reception of radio waves. The unit of frequency, the hertz, as you mentioned before, is in honor of Hertz's experiment with radio waves, which solved two problems. First, he had demonstrated in the concrete that Maxwell had only theorized that the velocity of radio waves was equal to the velocity of light. This proved that radio waves were a form of light. Second, Hertz found out how to make the electric and magnetic fields detach themselves from wires and go free as Maxwell's waves, electromagnetic waves.
Well, that about summarizes electromagnetic waves. Does anyone have any questions or comments?
Wow, I learned so much.
Good for you, Calder. Class is dismissed.
Yeah.